All right, let's go ahead and get things started. So, last time we we decided, well, you guys asked for us to just go ahead and go on to the chapter round from 2017 instead. And yeah, that's what we're gonna do. So, this time we're going to talk about the chapter round from 2017. But there actually was, oh wait, there's only chapter. Okay, it goes chapter, state, national. Okay, okay. Huh, for some reason I thought there was a school round. Oh well. So for 2017, we're gonna go over the chapter round, and then we're gonna go into state from there, and then maybe we'll cover some questions from the national. We'll see. But yeah, so we're gonna go ahead and take a look at the 2017 chapter round, starting with the sprint round. So let's go ahead and take a look there. So hopefully you guys had some questions that you guys were able to do, and then from there we'd be able to talk about that. All right, so starting things off with problem number 1. Well, problems 1, 2, and 3. Okay, problems 1, 2, and 3. So Gracie, did you get to do any of these, or did you do all of these?
I didn't do any of them, but the first one would be 21.
Yeah, first one's 21, pretty straightforward. I don't think it's that hard, right? Do I need to explain this? Anyone?
No.
Okay, all right. Problem 2 as well then, I guess.
You can skip the first 3.
Yeah, that's what I figured. Allison, Isabel, you guys are good with skipping here too, right?
Yeah.
Okay. Nothing too hard here. First one's 21. The idea is you just round it down, just in case someone's watching the replay, right? Problem 2, you're just rounding to the nearest 100. Again, this is rounding. The idea is you look at the digit afterwards. If it's 0, 1, 2, 3, 4, you round down. If it's 5 or up, you round up. 300. Well, it's pretty close to 300, so yep. Debbie counts by 5s. First number is 110. You can just kind of count yourself. 110, 115, 120, 125, 130. Okay, moving along. Chapter round's always pretty easy, first few. Problems 4 and 5. What is the difference between 7 times 6 and 5 times 4? Again, you just kind of do this. 7 times 6 is 42. 5 times 4 is 20. Subtract them, you get 22. Problem 5. A carton of 1 dozen jumbo eggs has a total weight of 32 ounces. If the carton itself weighs 2 ounces, how much does each egg weigh on average? Express your answer as a decimal to the nearest tenth. Gracie, just kind of explain how to do this one, I guess.
You subtract 2 first because it's asking for the eggs.
Right.
So 12 eggs is equal to 30 ounces. Then divide 30 by 12.
Yep, and then when you're dividing through that, what you can do to make the division a little easier, just go ahead and cancel out any common factors you have. 30 and 12 both have a common factor of 6, so what you're really looking at is 5 over 2, which is 2.5. Okay, no questions, right? Keep going, I guess. Problems 6, 7, and 8. Okay, Allison, problem 6.
240 times 3, 720.
Yep, problem 7.
So first you go from order them from least to greatest, and then cross out for every one less. For everyone on the least side, you cross out 1. For everyone on the greatest side, you cross out 1. And then you're just left with 94.
The other way you could do this is you could just count up from the smallest to the biggest and say, okay, I have 7 scores. My middle one, my 4th one is going to be my median, and then you could do it that way too. But yeah, 94 is your answer here. Problem 8. Still you.
Okay, half of the students joined. 13 students did not. The other half of the students that did not join is 13. And then there's the other half that did join.
Yep.
13 times 2, 26.
Yep. Nothing too hard yet. Let's keep going, keep going. Problems 9 and 10. Okay, Isabella, problem 9.
So for problem 9, we know that, well, for me, I got rid of the denominator. So I multiplied 100 by 0.1 to get 10, and then multiplied 10 over 0.1 by 0.1. So the denominator gets canceled out. So the final answer is just 10 minus 10, which is 0.
So there's a problem with what you did. And the problem is, had your answer not been 0, you would have gotten it wrong. Do you want me to explain why?
Wait, but it gets the same answer. It's just a different
It's
way.
because it's 0, it works. Had this been anything else, you would have gotten it wrong. For example, had this been 110, oops, let's use a different color. Had this been 110 minus 10 over 0.1, try that. What answer do you get here with your method?
Oh, then you get like a decimal or something.
No. You would get 1. Because if you do your method here, you multiply everything by 0.1, you get 11 minus 10, which is 1, right?
Yep.
But the correct answer here is 10. So what you're really doing is when you're multiplying by 0.1, you are multiplying both sides by 0.1. So then this becomes 11 minus 10, which is equal to 1, which is indeed 10 times 0.1, but that is no longer your original answer. Does that make sense, Isabella?
Yeah.
The reason why in this question it did not change is because this is equal to 0. 0 times 0.1 does not change. But had this been any other number, you would have gotten it wrong. Does that explain it?
Wait, so what do you do for the first step in this question then?
You can multiply by 0.1. You just need to remember at the very end to divide by 0.1 again. Because if I divide this by 0.1, I get back to my original problem. I get back to my original number. But then at this point, you may as well just go ahead and do this division by 0.1. Division by 0.1 is not hard. Division by 0.1 is the same thing as multiplying by 10. The reason why is because 0.1 is the same thing as 1 over 10. So 10 divided by, well, 1 over 10 is the same thing as 10 times 10, which is 100. So if you want, I would highly recommend memorizing the decimal forms of fractions with up to denominators of 12. I would highly recommend that. It really helps you save a lot of time in school and everything. So does that kind of explain the two different ways that you could do this?
Yeah.
Yeah, so really would definitely recommend memorizing decimals of like 1 over 2 all the way up to like 1 over 12, 2 over 12, 3 over 12, so on and so forth. 2 over 12 and 3 over 12 actually have simpler forms. It's 1/6 and 1/4, so you don't have to worry about those. But like 1 over 12, 5 over 12, 7 over 12, for example, you do want to memorize those. I think those, well, 12 less so, but up to at least 10 and 11 as well. I think 11 is good. But yeah, so that's really just it here. So does that explain why multiplying by 0.1 here gets you the wrong answer?
Yeah.
Okay. But it just so happened that because you were looking at 0, because everything ended up being 0 here, it ended up not being a big issue. All right, problem number 10. Still you, Isabella.
Okay, so we start at 10 and then we end at 20. So yeah, so we basically realized that if there is, I think, 6 gaps, then we're counting by 2s. So then it's 10, 12, 14, 16, 18, and 20. And
so we can kind of draw that out here. 12, 14, 16, 18, 20. It does work, right?
Yeah. So from C to D, there's like 3 spaces. And yeah, you can't really count like dot. You have to count like the spaces. So 3 times 2 is 6. So CF is 6 units long.
That's exactly it. Sounds good. All right, moving right along. These questions again are all pretty easy, so should not have too much of an issue until later on. Problem 11. The number of 8th graders who responded to a poll of 6th and 8th graders was 1/4 the number of 6th graders who responded. If a total of 100 students responded, how many of them who responded were 6th graders? Okay, Allison.
Didn't do this one, but so first of all, ratio from 6 to 8 is 1 to 4.
So 6th graders to 8th graders, you're saying is 1 to 4?
So 8th graders has less than 6th graders.
Okay. So 8th graders to 6th graders is 1 to 4.
Yes.
Okay, so 8th, I keep on forgetting. 8th to 6th is 1 to 4. Okay, sounds good.
Okay. And then you just set up a proportion. X over 100 is equal to 4/5, and then solve for X.
So where did you get that 5 from?
You add up the 8th and 6th graders.
Yep, so you can also say 8 to 6 to total, for example, is 1 to 4 to 5. And then at that point, you know, okay, X over 100 is equal to 4 over 5. So what is X?
80.
Yep, and then you could also say, what if I have an N amount of 6th graders? Then I have N over 4 for 8th graders, then N plus N over 4 equals 100. There's a couple different ways that you can do this one. All right, problem 12 and 13. Gracie, let's have you do problem 12. Problem 12, I think, is the first problem that has any challenging bit at all. So let's see if you can do this one.
So there are 12 small triangles.
Yeah, so the individual triangles of a single one, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Okay.
And for the triangles of size 2, I think there's 2 or 2.
Yeah, because this triangle right here is a triangle of size 2. This triangle over here is a triangle of size 2. If you ever try to make another triangle like that, you'll turn out to be some sort of quadrilateral, right? So it turns out that those are the only 2 triangles that you can make of size 2. But I think it's a little bit easier to look at the triangles like that with the corner triangle all at once instead of looking at them size 2, size 3, size 4, instead of doing that. So we have this triangle here, then we have this one, then we have this one, then we have this one, and this one, right? Right, Gracie?
Yep.
And then at that point we stop, right? Because if we keep going, this is no longer a triangle. This is now a quadrilateral. But what other triangle do we have?
The big ones.
The whole thing, right? The whole darn thing. So we put this whole thing together, that's another one. So how many triangles do we have on just this one half of the side that included the bottom left? 1, 2, 3, 4, 5, right? So what can we do?
12 plus 2 plus 2 plus 1.
Well, sure, or we can just say 12 plus 5. But how many times do we add this 5?
1.
We actually add it twice.
Oh, twice.
Because we have the triangles here and the triangles here. And then we add the one that is the whole thing. Does that make sense?
Yeah.
The idea is, well, this figure looks the exact same on the right half as the left half. So let's count one side and then just double it for the 5s. Your final answer here is 23. Look good.
Yeah.
Okay. Problem number 13. Keep going, I guess. Gracie, keep going.
For this one, I'm not sure actually. It's 7 to 5, so I think it has to be I think each one would be 3. So I think there would be 15 cats.
Now that is true and that is correct, but let me kind of explain it a little bit, right? So if I have a ratio of 7 to 5 for dogs to cats, then the number of dogs I have is 7 times x, where x is some unknown number, right? So dogs is 7x, and then cats equals 5x, right? Because this way they're in a ratio of 7 to 5. Well, what I'm looking for is 6 more dogs than cats. That would be dogs minus cats equals 6, which means 7x minus 5x equals 2x, which is equal to 6. At that point, I find out that x is equal to 3, which would mean that my cats is equal to 15. That's the idea here. So what the method that you did do it is correct. You just didn't have a very good explanation for it. Does that sound good, Gracie?
Yep.
All right, moving on. Here we go. Problems 14 and 15. Okay, Isabella, 14.
So we know that YZ is the base and area is base times height times 1/2. So if the area is 30, so 30 equals 5 times H can be used for XY.
Sure.
Times 1/2. So 5 over 2H. So I just like multiplied some constants. 5 over 2H equals to 30. So
right.
H equals 30 times 2 over 3. And it's the
2 over
reciprocal
3.
because you want to get rid of it. And then so H is 12. So XY is also 12.
Did you mean to say 2 over 5? 30 times 2 over 5?
Yeah.
Okay, because you said 2 over 3, I think. But yeah, your answer is indeed 12.
I meant 2 over 5.
So what if they had asked you for XZ instead? Would it be pretty easy to find at that point?
Yeah.
Well, what is XZ? Just for practice.
XZ would equal to 25
You don't have to
plus
do that.
144.
You don't have to do that. Why do you not have to do that?
Because it's also, I think it's a Pythagorean triple.
It is. Do you remember what Pythagorean triple this is?
5, 12, 13.
Yep, it's 13. That's what I meant by you don't have to do that. Like, sure, you can do it that way, and that would be correct, right? But you have to find the square root of 169, and if you don't remember that off the top of your head, it's not that easy. But yeah, so that's why I said working with Pythagorean triples saves you a lot of time, right? Then this is one of the examples. If you had been asked for the hypotenuse instead, yeah, you would need to find what your leg is first. Oh, it's 12. Oh, 5, 12, 13, right? That would be a lot faster than anything else that you could do. All right, problem 15. Allison.
Uh, 9.
Yeah. Does anyone need an explanation here? So just briefly, the negative power here means I take the reciprocal of what's on the inside first. So this becomes 3 to the power of 2 now. And then 3 to the power of 2 is, well, 9. Okay. Moving on. Wow, this one's quick. Chapter round is easy, huh? Oops. I think it froze or something. It's not working right. One sec. Okay. This one. Problem 16, 17, and 18. All right. If the sum of the positive integer a and 5 is less than 12, what is the sum of all possible values of a? Okay, Allison, let's have you do this one as well. Last question was pretty quick.
A is less than 7.
So what does that mean a could possibly be?
I mean, lots of things.
Yeah, but just list them all out. There's not that many anyways. You can list them all out.
1, 2, 3, 4, 5, 6.
Okay, and we want to add up all of those numbers, and how can we do that? Well, one way to do it is just, add them one by one, but that's not great, right? We don't want to do that. Is there any other way to do it?
Is it 11?
The sum of all those numbers is 11?
1 plus 2 plus 3 plus 4 plus 5 plus 6.
Yeah, you're telling me that's 11? How did you do it?
Okay, 4 plus 6 is 10, 2 plus 3 plus 5 is 10, and then there's a 1 left over.
Yeah, so wouldn't that be 21, not 11?
Oh, there's 2 10s. Oops, yeah.
Now, you could do that. And yeah, that is fine. But what if I had asked you for the sum of the numbers 1 up to 40 instead?
Would be slow. I do not know the tricks.
You don't know the trick? Okay, Isabella, do you know it?
I put it in the chat. It's like n
Oh, okay.
plus parentheses n plus 1 over 2.
N times n plus 1 over 2. That is right. Yeah, that's the formula. So in this case, Allison, when you're adding up numbers from 1 up to n, so in this case, we're looking at like 1 plus 2 plus 3, 1 plus, oh my, it's purple again. Like 1 plus 2 plus 3, all the way up to plus n. This is always equal to just n times n plus 1 over 2. Have you seen a proof for this before, Allison? Like, does this ring a bell, or have you never seen this before?
Not any sequences, so no.
Okay.
Actually, wait, no, you did tell me it once while we were discussing sequences, but I did
Yeah.
not remember.
I think, yeah, I'm pretty sure I've talked about this before, but yeah, so this is how it works. And in this case, our n is 6. So our formula is just 6 times 6 plus 1, 7 over 2. Well, 6 times 7 over 2 is 3 times 7, which is 21. Look good, Allison? Okay. Yeah, I think that's probably good here then. Problem 17. Gracie?
You add them all up first.
Well, you're already told that there's 360 total students.
Oh.
So you can save that step.
90 out of 360 people bike to school. And then you need to find the percentage of that, which is 25%.
Yep. Simplifying that fraction, 90 over 360, that gives you 1 over 4. That is 25%. Yeah. Yeah, that's really just it here. Problem 18. Do you want to do this one too, Gracie, or do you want to give this over to Isabella?
I'll do it.
Okay.
I actually don't really know how to do this one.
Okay. So one way you can think about this is you can say that, so think about it this way, right? Instead of saying like 18 large jugs and 30 small jugs, think about it this way. Say that 18 large jugs and 30 small jugs are the same, right? So what this means is that the weight of them should be the same, right? Does that make sense?
Yeah.
So what I can say is that 18L is equal to 30S. Does that sound good?
Yeah.
Okay. So if I know that 18L is equal to 30S, then I can simplify this down, can't I? So what can I simplify this down to?
3 over
Well, what L equals what S? Just give it to me in that form.
3L equals 5S.
Yeah. So if I already have 25 small jugs, how many more small jugs can I fit?
25 small jugs would be
How many left? How many more?
5 small jugs. So
Yeah, so how many large jugs is that?
3.
Does that sound good?
Yep.
Yeah, that's pretty straightforward, I think, right? Do you agree with me?
Yep.
It's just you just have to think about it the right way. All right, moving on, problem number 19 and 20. Okay, Isabella, these are yours.
So for number 19, 1/2%, like 1/2 is 0.5. Percent is like the definition of percent is like 1/100.
Right.
So like you just multiply them together. So 0.5 times 0.01 is 0.005.
Yep, 0.005.
Yeah.
That's your answer.
Yeah.
Okay, and problem number 20. Can you do this one as well?
Yeah. So x squared plus 5x plus 6 equals 0. So I don't know what they call it, but it's like the one where you put like the x on one side and then you put like the 6 on one side and then you sort of like find the factors of 6 or something.
I see. I know. I see what you're saying. So what you're saying is you want to find two numbers that add up to 5 but multiply together to 6, right?
Yeah, that one.
So that's x plus 2 times x plus 3, right?
Yeah.
This process is called factoring.
Oh, right. Okay. Yeah. That's
and then this is equal to 0. So what are my two solutions for x?
X could equal to -2 or -3.
Oh, okay, yeah. Oops, I don't know why I wrote 5. But yeah. So what is the sum of your solutions then?
-5.
Gracie, Allison, are you both familiar with this process of factoring?
Yeah.
Okay. So no explanations there. But the idea here is, yes, this is one way to do it. This is the slowest possible way to do it. Well, not the slowest possible way. Well, probably the second slowest. There's a faster way. And that way is just to say, okay, this is 8x squared plus bx plus c. My answer is -b over a. And you're done. Now, why does this work? The reason why this works is because of what is called the do you guys know the quadratic theorem? Not the quadratic theorem. The quadratic formula.
Yeah.
What is it, Allison?
-b plus minus square root b squared minus 4ac all over 2a.
Yeah. So if I have my two solutions, if one of them is this plus this, and one of them is -b minus the square root of b squared minus 4ac all divided by 2a, then if I add them together, I get that this cancels out with that, and I get -2b over 2a, right? So the sum of my solutions is always going to be -b over a. Questions, comments, concerns? Likewise, if I'm looking for the product of my roots, if I look for this, if I multiply these two, this becomes -b squared minus b squared minus 4ac, all divided by 4a squared. B squared cancels out. I get positive 4ac divided by 4a squared. My answer is c over a. So c over a is the product of my roots. -b over a is the sum of my roots. All this proved by using the quadratic formula. Any questions? So that's actually all that I thought we would get through, but looks like we were a little quicker than I originally had thought. So we can take a look at the next few problems as well. Okay, problems 21 through 23. may as well just go ahead and go here. Okay. 21 through 23. What is the quotient when 1000 is divided by 2 to the power of 3 times 5 squared? Okay, Isabella, do you still want to do this one?
Yeah.
Sure.
So basically it's just 1000 divided by 8 times 25. To simplify that for us, it's 1000 divided by 200, so it's just 5.
Yep. We could also look at the prime factorization of 1000 instead, which would be 10 to the power of 3, which is 2 cubed times 5 cubed. Well, all that's missing is 1 extra 5, right? So the answer is 5. Okay, problem number 22, Allison.
Uh, 3 miles. First half mile and then that. 2.25 plus 0.75x for every mile.
Okay, so what you're saying is, okay, so you're saying, wait, can you start over? Sorry.
Okay, 2.25 plus 0.75x.
And what does this x represent?
X represents how many miles subtracted from the half, which is 2.5 miles.
Really? It's 2.5? That's what we put here?
No, because we need to then multiply that by 4.
So why do we multiply this 2.5 by 4?
Because that's for every mile, but the 0.75 is for every fourth of a mile.
Okay, so shouldn't we be dividing this 2.5 by 1/4? Why are we multiplying it by 4?
Because the 1/4 is 1/4 of a mile.
Well, the answer here I was looking for was dividing by 1/4 and multiplying by 4 are the same.
Oh, are they the same?
Yeah, divided by 1/4 is equal to multiplying by 4. These are the same thing.
Yeah.
So we are indeed dividing by 1/4, but that is the same thing as multiplying by 4. So how many, what is x equal to?
10.
Okay. So our final answer is?
77.25.
77.25. Whoa.
Wait, no.
That's a lot of money for a 3-mile ride.
That's 7.5. 9.75.
9.75 it is. All right. Problem number 23. Gracie.
I need to read and evaluate it first.
So how do you want to do this? What can we do to set this one up?
96 minus 40.
Wait, so why are you doing 96 minus 40?
I'm trying to figure out how many 8th grade boys there are.
Yeah, and that is what the question asks for, right? So there's a couple different ways that we can set this up. One way is to set up a table. So the way that we would set up this table is we would say, okay, your grade goes here, and then your gender goes here. So then this would be a table kind of like, okay, boys, girls, and then total. And then over here, you would have 7th, 8th, and total. So how many of your total do you have?
150.
150. Okay. So everything here should add up to 150. So what is your total, boys?
54.
And your total, girls?
96.
So your rows here should add up to 54. Your rows here should add up to 96. Does that make sense?
Yeah.
What are you looking for? You're looking for 8th grade boys. So we'll leave a question mark there. How many 7th graders do you have in total?
68.
How many 8th graders do you have in total?
82.
So this column should add up to 82. This column should add up to 68. Does that make sense?
Yeah.
So how can we find the total number of 8th grade boys? We will need either this number or this number first. And what do we know? We know that 40 of the girls were 7th graders. So where does that go? 1, 2, 3, 4. Where does that go?
3.
So that 40 goes here. So now using this 40, I can find either this number or this number. It's entirely your choice. Which one do you want to do? 1 or 4?
1.
Okay, sure. What is this number going to be?
28.
So what does that mean this number is?
26.
Pretty easy, right? You just need to set it up the right way.
Yeah.
Any questions?
No.
But yeah, now that you see that, right? Now that you see that we set it up this way, question becomes a lot easier, right? So there's a couple of things about this setup. This setup is one that you will need to use a lot on the SAT. And I think this kind of question does actually come up fairly often on the SAT, like at least 1 or 2 every single exam. So this is something that you will see on your college entrance exams. And this setup, big things you have to remember. You have to remember to use the total column and the total row. That is the most important row, actually, because that is the only thing that will relate everything together. Because otherwise, you don't know what these numbers add up to. You don't know what these numbers add up to, right? That's when you need that total row. That's why that row is important. Okay. Any questions on this problem here?
No.
Isabella, did you have a question or did you want to do it?
I wanted to do it.
Okay. We'll let you have the next one, okay? Let's see. Problems 24 and 25. Again? Oh my. Okay. That's fun. It crashed while opening. Oh my. That's fun. Sorry, this app is crashing for some reason. Like it feels like it shouldn't crash because of how basic it is, but it just crashes all the time. Okay. 24 and 25. 24. What is the largest sum that results when one of the arrangements of the digits of 2017 is added to one of the arrangements of the digits of 2016 if none of the digits 0, 1, or 2 can occupy the same position in both numbers?
So 0, 1, and 2 can't occupy the same position. So the only the only number in like the 2 different numbers that don't really have a restriction to it is 7 and 6. And
Sure.
like really nicely, I guess, both of them are also the greatest number in that little set.
Yeah.
So naturally 7 and 6 is going to be the 1000th digit in the new number. So we could do 210 for 2017, but since it is the greatest value we can get, naturally we want to match that in the 2016, but that's not possible since it can't occupy the same spot. So we know that 7,200, like the 2017 is going to be pretty much 1,000 greater than 6,000. like not 6,000, but 2016. So we want to
Right.
make sure that like the 6 is sort of greater a little more, I guess. So you put the 2 in the position. Wait. Oh wait, no, you put the 2. Yeah, okay. So we know that 7,200 is definitely going to be more greater than 6,200. So 7 gets to keep the 2 in the hundredths position. So that means 6 can't have 2. It can only have 1 or 10. And the next greatest one is 10. So 6 is going to have 6, 1, and then 2 or 0. And yeah, that basically just gets the greatest amount.
So your total sum of all this is 13330.
I think it can be made greater though. Oh, yeah,
what's the
it
problem
can
here?
be made greater. 72010 should be 7201. That way.
Why
if
does
you
it need to be 0, 1?
Well, that way 6,100 can be greater.
So I think you're getting a little confused here. So first off, this actually isn't allowed because the digit 0 cannot occupy the same spot either. So this isn't allowed. Does that make sense?
Oh, okay, then it is 6201.
So, well, 6201, 2 would match up then, right? Which also can't work. So what you want to do,
Sorry, I meant 7.
7201. Okay, so 7201 is fine. And the reason why this is the difference that you want to do is the following. So I do agree with you. You do want to put the 7 and the 6 up front, right? Because if you put 7 and 6 at the front, this makes your number the biggest. Then you want to have 2 in your 100 spot somewhere. In actuality, 7210, 7201 and 6120, these two added together is the exact same thing as 7120 and 6201. Adding up these two numbers gives you the exact same end result. Does that make sense?
Wait, but I think you added wrong though.
No. I didn't update this number. This ends up being
Okay.
13,321. But yeah, so the sum of these two numbers ends up being the same. Does that make sense why? Because we can
Yeah.
think of 7201 as equal to 7,000 plus 201. And then 6120 as equal to 6,000 plus 120. So that's why these two things end up being the same. Well, if we think about it that way, then all that matters is, okay, my 7 and my 6 are at the front. I don't care about that anymore. I just care about these numbers now. So here, I do agree that you do want to put the 2 and the 1 in the hundreds, one at a time, because that is that's your best way to make your number. And then at that point, your 0 needs to be in the 10 spot and the 1 spot at some point, which means that your other 10 spot, you want to put your 2 because, well, 2 is bigger than 1. So that's the idea here. That's the general idea here. You just need to think about them kind of like one spot at a time. But yeah, that's really about it here. Any questions on that? It's just really just step-by-step logic your way out. All right, problem number 25. How many pairs of positive integers, x and y, are solutions of x over 12 plus y over 36 is equal to 1? Okay. Sure. Isabella, let's have you do this one as well.
I think I know how to do this one. Like earlier in the week, I don't think I got it. But first, I think I have to get rid of the denominator. So,
okay, so how would you get rid of that?
Yeah, multiply by 36.
Okay, so what does that give you?
Like 3x plus y equals 36.
So you're also told that these must be positive integers. So what are the possible values for x first?
Like 1, 2, 3, 4, 5. Continue.
Does this go any further? Actually, does this go any, like, can I go
Yeah,
on?
it does.
It goes on infinitely?
I think is it just factors of 36? Then
No, I have 7, don't I?
then it does go infinitely.
Does it? X and Y both need to be positive, right?
Yeah.
What happens when X is equal to, say, like 14?
It's greater than 36.
Which means Y must be,
A negative. Oh, so it can't be greater than like 12, I think.
so what happens when X is equal to 12?
Y is 0.
Is that allowed?
I mean, it's positive, sort of.
Is 0 positive?
Wait, but 0 is not anything.
0 is neither positive nor negative, so no, 12 is not allowed either.
Yeah, so it's just up to 11.
So X can be anywhere from
Oh.
1 to 11. Everything here, Y has a value for it. So your answer
So
is
it's the
11.
11.
We don't even
Oh,
need to
okay.
find the pairs of, we don't even need to find what Y is. We just have to figure out, hey, if X is anything bigger than 11, Y can't be positive. If X is anything smaller than 1, X is not positive. So those are my answers. That's really it. It's not that hard. Right?
Yep.
Okay. Gracie, is Allison, any questions here?
No.
Gracie?
Not really.
Okay. 26, 27, 28, as well as 29 and 30. Let's see if these questions have anything to them. Problem number 26. What positive value should replace X in this statement to make it true? Okay, Allison, do you know how to do this?
X plus 1, X minus 1 multiplied.
Okay, so what you're saying is X
Right.
squared minus 1 is the same thing as X plus 1 times X minus 1, right?
Yeah, but I don't know why that helps.
You don't know why that helps? Maybe not yet, but let's take a look in a moment, okay? So what do you notice about this though? What is 55 times 59? Do you know what that is?
Can't do it on the top of my head.
You can't, but does this look like anything to you? Does it look like an X plus something times X minus something? Like, does it look like an A plus B times an A minus B?
I have to say, kind of.
In fact, this is actually 57 plus 2 times 57 minus 2. Well, I flipped the order, but do you get it?
Yeah.
Okay. And then what about 53 and 57?
55 minus 2 and plus 2.
Okay. So what is 57 plus 2 times 57 minus 2? What is that equal to? In terms of squares.
57 squared minus 4 squared.
Minus 4 squared?
Wait,
You
no, 4.
minus 2 squared?
Yeah. Which
Okay,
is
and what is
4.
that subtracting over here?
55 squared minus 2 squared.
Okay, so then this actually, 2 squares cancel out. So this ends up being 57 squared minus 55 squared. Would you agree?
Yeah.
And what is that equal to?
X, that seems like a lot like X minus 1. X squared minus 1.
Well, we'll take a look at that later in a sec, okay? So what is 57 squared minus 55 squared equal to?
Can't do it on the top of my head.
How about 57 plus 55 times 57 minus 55? Does that look a lot easier?
Uh-huh.
So what is 57 plus 55?
112.
What is 57 minus 55?
2.
What is that equal to?
114.
112 times 2 is equal to 114.
224.
Okay. And that is equal to x squared minus 1. What can we do now?
Solve for x.
Add 1 to both sides and then square root it.
Yeah.
So what is that?
2 square root of 223.
Add 1 to both sides and you get 223?
Oh, wait, it's adding 225. Oh, it's 15.
If this is minus 1, so you add 1 to both sides to get rid of it, right?
Yeah.
Yeah, so then you get 225, you square root that, you get 15. This question is not hard. You just have to be very familiar with the a plus b times a minus b idea. And if you are familiar with that, this question is very simple. Okay, problem 27. The Pythagoreans proved this pattern. Nicomachus discovered supposedly this pattern down here. What is the value of s in this equation? Okay, Isabella, are you down? Isabella?
For this one, I know that 1 cubed plus 2 cubed plus dot dot dot. I mean, kind of continues until n cubed. So 1 plus 2 plus something 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 plus n, and then that's in parentheses, squared equals s squared, because they want value of s.
So you're saying 1 plus 2 plus 3 dot dot dot, like this squared is equal to s squared?
No, there's also an n in the parentheses.
Like plus n, like that.
Yeah.
That is not what we're doing here. Okay. Let's explain this a little bit more. Okay. So what you notice here is that this is 1, right? And then you see this 3 plus 5, 7 plus 9 plus 11, 13 plus 15 plus 17 plus 19, right? Do you see that?
Yeah.
Okay. So what happens if you do 1 cubed plus 2 cubed? What do you notice that is?
Is it just like
In terms of these
above?
numbers here?
I'm not sure then.
You're not sure about that?
Like, what do you mean?
Like 1 cubed plus 2 cubed is equal to 1 plus 3 plus 5. That's what I'm saying.
Oh, yeah.
Okay. Okay. So what you said here is that this is equal to, what you were saying was that this is equal to 1 plus 2 squared, which is indeed true. So what you're saying is 1 cubed plus 2 cubed plus, so, okay. So what you're saying is 1 plus 2 plus 3 dot 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 plus n squared is equal to s squared. So where did you get this from? Where did you get this 1 plus 2 plus 3 plus all the way down to n squared from? Where did you get that from?
Wait, am I supposed to use cubed, I think?
Can you be a little bit more specific?
Oh, I think, is it parentheses 1 plus 2 plus 3 dot 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 plus n cubed equals s cubed?
Okay, I think you're just confusing yourself at this point. Okay. All right. I'll just explain this one, okay? Does that sound good? Yeah, I think this one's a little bit difficult. So what we see here is this right here is 1 cubed is just 1, 2 cubed is 3 plus 5, 3 cubed is 7 plus 9 plus 11. So what do we actually notice here? So what we notice is that 1 cubed gives us the first number here. 2 cubed gives us 2 more numbers here. So from 1 cubed we have 1, that's equal to 1 squared, right? 1 cubed plus 2 cubed is actually equal to 3 squared, because then we add on 2 more numbers here. Adding on 3 cubed gives us 7, 9, and 11, so that would be equal to 6 squared. Does that sound good, Isabella?
Yeah.
What we can notice is that this plus 1 divided by 2 is equal to this squared, right? So the last number that we add, plus 1 divided by 2, is the square of what we're doing. So if we add up the cubes from 1 to 4, this plus 1 is equal to 20, divided by 2 is equal to 10. These all added up, cubed should equal 10 squared. And adding on the 5th cube should give us 5 more down, which is 5 squared. And what you notice at this point is we're really just adding together how many numbers there are here, which is just 1 plus 2 plus 3, ... plus n squared is equal to 1 cubed plus 2 cubed plus 3 cubed plus n cubed. This is what we're looking for. So in other words, if this is equal to s squared, then s is equal to 1 plus 2 plus 3 all the way down to plus n. In this problem, n is equal to 8. 8 times 9 over 2, your answer is 36. So the pattern here is you should recognize that 1 cubed is equal to 1 squared, 2 cubed plus 1 cubed is equal to 3 squared, 1 cubed plus 2 cubed plus 3 cubed is equal to 6 squared. This is equal to 1. This is equal to 1 plus 2. This is equal to 1 plus 2 plus 3. 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed is equal to 10 squared, which is equal to 1 plus 2 plus 3 plus 4 squared. This is the pattern that we're looking for. Does that look good to you, Isabella?
Yeah.
Gracie, Allison, does that all look good to you guys as well?
Yeah.
Mhm.
Okay, so that's probably going to be it for here today. We have a couple questions left in this this exam, but I think we can go ahead and leave them for next time. So next time we're going to go ahead and take a look at the last 3 questions here, and then we're going to go into either like the target or the team round. I think we can do the target round first and then do the team round after. But yeah, so that's what we're going to look at next time. So with that, that's going to be it for here this week. I'll see you guys after the break. All right.
See ya.
Bye.
See ya. Bye.
So is the homework the target or the team?
We're probably going to actually be able to do both.
Oh, okay.
So yeah, take a
Thank
look
you.
at both. Yeah. See ya.
Bye.
Bye. Bye.